Hello everyone, welcome back. Here is vanAmsen. Today we will be solving an interesting problem, search a 2D matrix. So this is problem from LeetCode and it's medium difficulty problem with ID of 74. So the problem is as follows. We are given an m times n integer matrix where each row is sorted in non-decreasing order. And the first integer of each row is greater than the last integer of the previous row. So our task is to write a function that takes this matrix and a target integer and return true if the target is matrix or false otherwise. So the catch is we need to solve it in O log m times n time complexity, which suggests we should use a binary search approach. Now you may wonder, how can we apply binary search to a 2D matrix? Well, here is a trick. Even though the matrix is 2D, it's sorted in a such way that we can treat it as 1D array. And binary search works perfect on a sorted one-dimensional array. So this is our matrix. So it's starting from 1 and end at 60, and target number is 3. So yeah, our target is 3. So let's track what's happening in our binary search. So we will have left pointer, right pointer, mid pointer, so it's index, and also we have matrix. So matrix, and here we have mid row and mid column. So it's getting 0, 11. So here is 0, here is 11 index, and mid is 5. So here is the mid with value. So it's value of middle index, value of 5. And then we have 0, 4, 2, 5. And because it's our target is 3, so it's 0, 1, 0, 1. And then we go to the right. So it's 1, 1, 1. And at index 1, we have 3. So 3 is our target. So we output true. So as you can see from the output we tracked, we have left at 0 and right at 11. The total number of elements in the matrix minus 1. And the midpoint, mid, and the value at mid in the matrix are also given in this simple table. So in the first iteration, mid is 5, and the value at mid, which is the element at row 1 and column second column, is 11, and since 11 is greater than the target value of 3, so right is updated to mid minus 1, so it's position 4. So we are considering, so we don't consider this part, and we try to consider this part. So here is our updated value, and in the second iteration, mid is also updated to 2, and the value at mid, which is the element, will be then 5. So this is our new mid. So mid corresponds to this mid, and since 5 is still greater than our target value of 3, right is again updated to mid minus 1. So then we have here our left index, and here we have right index, and we don't consider this part as well. And in third iteration, mid becomes 0, and the value at mid of 0 is 1. So our mid becomes here, and because 3 is greater than value of 1, we go to the right. So then our mid becomes mid plus 1. So we jump here. And in the fourth and final iteration of our algorithm we will implement, mid becomes 1 because if we go to the right, so it's mid plus 1, and if we go to the so right, and if we go to the left, it's going to mid minus 1. So and this become mid of value 3, and this is exactly the target value, so the function returns true. And yeah, so let's implement it, and I will explain what we are doing step by step. So if not matrix, return false. So first we check if the matrix is empty. If it is, we return false because an empty matrix can contain the target. And M and len matrix, len matrix 0, and left, right, 0 m times n minus 1. So next we iterate m and n to be number of row and column in the matrix. And we also set left to 0 and right to m times n minus 1, and this represents the start and end of our array. So now we will start the binary search. While left is less than or equal to right, we calculate mid as the midpoint between left and right, and we then calculate mid row and mid column by dividing mid by n and finding the remainder. And this is equivalent of mid position in two-dimensional array. So while left less equal right, mid left plus right, modulo with remainder 2, mid row, mid column, diff mod mn. So and if the element at mid is equal to target, what we do, we have found the target and we return true. So if matrix mid row mid column equals target, we simply return true. Great. So if the element at mid is less than the target, we know that the target must be somewhere to the right of the mid. So we set left to mid plus 1. So else matrix mid row less than target, left will be mid plus 1. And if the element at mid is greater than the target, we know that the target must be somewhere left to the mid, so we set right to mid minus 1. So else right will be mid minus 1. And if we exit the while loop without finding the target, we return false because our pointer are not pointing anywhere, and it's the target value is not in the matrix. So we return false. Okay, great. So let's run for a given test case. So for this previously analyzed matrix, we should have true. So all good. And yep, so now we can run it for unseen test cases. Hopefully it will pass. So yeah, all good. And our implementation beat 93% with respect to runtime and 28% with respect to memory. Let's rerun it so to verify. Yeah, so it's really strange with memory. So the difference are 16.8, 16.9 megabytes. So as you can see, in second run, we have beaten 93% with respect to runtime, and with respect to memory, 90%. But both cases are similar. So basically, what we can see that those differences are just 0.1 megabytes, so probably some rounding or test cases. So our implementation is efficient, and that's it for this problem. And this is elegant solution that leverages the properties of the matrix to perform an efficient binary search. And if you are interested, I have also implemented this solution in C++, Java, JavaScript, C#, Go, and Rust. Especially I like implementation of Go and Rust. And you can find the code in the description below. And I hope you enjoyed this video and learned something new. And if you did, don't forget to hit the like button and subscribe to my channel for more coding problem solution tutorial in Go, Rust, Python, and other programming languages, and much more. And as usual, keep practicing, happy coding, and see you next time.